Alrighty, guys. So today we're going to be going over the final lesson before we catch up to the rest of the chem classes. Today we're going to be talking about something called chemical equations. Now, before we talk about this new stuff, let's kind of review some of the old material. So what we're going to do is we're going to be checking how many of each element there are inside of the compounds, the molecules down here below. So first we have CBD. And when we're trying to figure out how many elements there are, we got to look at the capital letters. So the first capital letter is C. So we got a carbon, and the number behind the letter tells you how many there are. So there are 21 carbons. Okay, the next capital letter is H, hydrogen, and there's a 30 behind it, so it tells us that there are 30 hydrogens. And then lastly, we got oxygen, which is O, the capital O, and there's a 2 behind it, so it tells us that there are 2 oxygens. All right, so that's CBD. Let's go on to one that's a little bit trickier. So we got K, potassium. There's a 4 behind it, so that means that there are 4 potassiums. If we look right here at Fe, Fe has a capital F and a lowercase e, so that means that this is all just one element. This is iron. And since there's no number behind it, it means that there's just one. There's just one. All right, now we got a C and an N inside of these parentheses. So those are the elements, carbon and nitrogen. Now there's a 6 on the outside the parentheses. So we just need to multiply everything on the inside by the number on the outside. So there are 6 carbons and 6 nitrogens. All right, now before we move on, one thing I do want to mention is that this entire formula is one molecule. It's one combined structure, okay? It's made out of these individual pieces. These pieces are like different Lego blocks, right? We talked about this example before. Lego blocks can come in different sizes, different shapes, different colors. And when you put them together, you make a molecule, okay? But this is all just one molecule together. All right, so let's talk about the new information for today. Oh, excuse me. All right. So the new information for today is going to be something called chemical equations. Now, an easy way to think about chemical equations is to think of them as recipes, okay? You start with certain ingredients, different chemicals, which we call the reactants. This is your starting materials. And then you make a product. You make something. Whatever you make, whatever chemical you make is called the product. And then we separate the chemicals with plus signs, the molecules with plus signs, and we separate the reactants and the products with an arrow. So we got an example right here. Chemical 1 and chemical 2 make a different chemical, okay? So easy way to think about this, again, is like a recipe. If you wanted to make lemonade, right? You would need some lemons. All right, that would be your first reactant. You would need some water. And you would probably want to add some sugar or it's going to be too sour. And then you will make lemonade. All right, so this is what a chemical equation basically is. It's a recipe. It tells you what you start with and what you make. Now, obviously, we're not going to be talking about lemonade when we do the chemical equations, but this is a good way to know how to write one. Your starting materials are going to combine to make an ending material. So let's look at a couple examples of chemical equations with molecules inside of it, okay? So we're going to do 2 examples. The first example, we're going to be looking at which chemicals are the reactants. Now, reactants, we said, are the chemicals that you start with, and which ones are products. This is stuff that you end with, or the stuff that you make. Now, reactants and products are very easy to distinguish. You just need to look on the left and the right side of the arrow. So the left side of the arrow are your reactants. They're your starting materials. And then the stuff on the right side are going to be your products. Okay. So let's look at the left side. So the left side, the reactants. If you look at the reactants, the first molecule that we have for our reactants is this guy right here. So the molecules are separated by the plus sign. And so we got Li2O. So that means we have one Li2O molecule. Okay. The second molecule, again, they're separated by plus signs, is H2O. So we have one H2O molecule. Okay, and that's it. You just need to look at the molecule formulas, and they are separated by the plus sign. All right, let's move on to the right side of the arrow. The right side of the arrow we said are the products. And if you look at the products, there's a molecule right here, LiOH. But if you guys take a look at the formula, there's a number 2. There's a big 2 in front of LiOH. That tells us that we have 2 LiOH molecules. Okay. So if there is a number in front of that molecule, it tells us that we have multiple of that molecule. Okay. If there's no number, it means there's just one. But if we have a number in front of it, it tells us that we have that many. So if this was a 5 or something like that, that means we would have 5 LiOH molecules. If the number was 100, we have 100 LiOH molecules. All right, so if you guys want, you guys can pause the video right now and just try number 4, and then you can check your answers with me afterwards. But I'm gonna stop real quick. If you want to pause the video and try it out, I recommend that you do that. But if not, let's go over the answer. So here, again, we're gonna separate the left and the right side of the arrow, and that's gonna tell us that what the reactants are and what the products are. Okay, there's only one chemical on the left side, and it's CaCO3. There's no number in front of it, so that tells us that we only have one CaCO3 molecule. Okay, now on the right side, we have 2 molecules because you got 2 things separated by plus sign. There's no number in front of it. That means that we have one CaO molecule, and we have one CO2 molecule. All right, so that's how you can read chemical equations. Again, they're just recipes that tell us how many molecules it takes to make a certain number of other molecules. Okay. All righty, let's move on. Now, we talked about this already, but just to reiterate, when a chemical equation needs multiple of the same molecule, you just put a number in front of it. So we saw an example earlier, but here we have a 2 in front of CO, which means that we need 2 CO molecules. There's no number in front of O2, so we only need one O2 molecule. And here we have a 2 in front of CO2, so we have 2 CO2 molecules. All right, so what we're going to do now is we're going to do some practice problems, basically doing the same thing that we just did. This will be a good way for you guys to practice for your assignment today. And so what I recommend is that you pause the video and try this out and just check your answers at the very end. Okay. You do need to include these 2 questions in your notes, so you do need to solve them. So just make sure that you're either following along with me, or you can pause the video right now and try it out and just check your answer at the very end. But let's go over these problems. Okay, so for number 5, again, we're going to separate the left and the right side. The left side tells us the reactants, and the right side tells us the products. So for your reactants, you should see CH4. There's no number in front of it, so we got one CH4. There is an O2, but there's a 2 in front of it, so there are 2 O2 molecules. Okay, let's go to the right side. Looks like we got 2 different molecules. The first molecule, the first product, is CO2, but there's no number in front of it, so we got one CO2 molecule. And then for H2O, we got a 2, so we got 2 H2O molecules. Okay. All right, same thing for this last one right here. We're going to separate the left and the right side. The left side are the reactants. The right side are the products. For the reactants, it looks like we have 2 separate molecules. We got one S8 molecule. And then we have O2, but there's a 12 in front, so we have 12 O2 molecules. All right, and then last but not least, for the products, the right side, it looks like we have 8 SO3 molecules. Okay. So if you guys pause the video and check your answers, hopefully this was helpful. But I'll give you guys the rest of the class period to work on your assignment. Let me know if you guys have any questions or if you guys want to check your answers. All right, good luck, guys.